Friends, welcome to my YouTube channel. So today I am going to solve the composite bar problem for the thermal stresses. So before this video, thermal composite bar thermal stresses, how the formula we got, these two formula I wrote here. Again we'll explain these questions and again I'll show the how we got this formula. If you remember these two formula, this problem we can solve. So this formula already previous video I told we derived already. How to derive this is there in the previous video. So what is the question they are asking? A steel rod is 20 mm dia. A steel rod is 20 mm dia. Passes centrally to the copper tube. So inside copper tube, 20 copper tube dia is 40 mm internal dia and 50 mm external dia. Both end are fixed. What they are asking? Close at the each end. So rigid. Both end are rigid fixed. Both end are rigid. So now, which bar will elongate more? So this depends upon the thermal expansion, coefficient of linear expansion. So alpha, that is linear expansion for steel is 12 and linear expansion is copper is 18. So that means linear expansion copper is more. So elongations will be more in the, this is what is steel. So this is elongation for the steel. So elongation, copper rod will elongate more than steel. So copper rod elongate more, that means compressive will come, and alpha, that is steel linear expansion will be tensile will come. So this already previous video already we discussed this, how this coming. So okay, so now how to solve these questions. So first dia they given steel rod. So solutions we write area of the steel. How much? Pi by 4 20 whole square will get. Then area of the copper. Pi by 4 external dia 50 whole square minus 40 whole square. So this both value will get here. So how much we calculated this? 100 pi. You keep it at the pi because once we'll solve it will get cancelled. Okay. So square. And this value is coming to 25 pi mm square. Okay. So for the equilibrium system, what is there? For the equilibrium system, load will be equal for steel here, copper and steel is there. Okay. So for the equilibrium system, load on copper, what is tensile load on steel. So right here like this, tensile load on steel will be equal to compressive load on copper. Why this? Because if thermal expansion, so again just highlight I am giving here. Suppose these two bar either steel and copper. Both end will be fixed. Suppose this is copper, this is steel. Both end is fixed. So already concept is there. If coefficient of linear expansions will be more, that bar will elongate more. So this bar will elongate more. This bar will elongate less. So if both bar is fixed, both end is fixed. So if bar wants to elongate beyond this, but what they will do? They will push back. So the compressive stress will develop. But still, what will happen still? They wants to be under this. Under this, it will reach up to here. So how it will reach here? Tensile. So here compressive stress will develop here. Tensile stress will develop for the steel bar. So tensile load of the steel equal to compressive load of the copper bar. So now what is the formula coming case 1? Already there, what is stress means sigma, what is steel? So give steel into A steel is equal to sigma copper is equal to A copper. Now area we know. So area will substitute here. So directly what will write here? Sigma S is equal to area of the area of the copper by area of the steel into stress of the copper. So this, what is the relations will come here? If we'll substitute area 100 into 25, so we'll write here that implies sigma s is equal to, if we'll substitute this 100 pi and 225 pi, this relations will come to 2.25 copper Cu. This is the relations coming for first case. Tensile load on the steel will be equal to the compressive load on the copper. So these two relations we are getting this 2.25 copper bar. Now we know the elongations will be both bar will be equal, case 2. So this is case 1, case 2, what is? Elongation of the both bar will be equal. So elongation change in length, no? Elongations delta N you write better. Elongations will be both bar will be equal. Elongations elongation of the steel will be equal to the elongations of the copper. If we'll solve this, how we got this formula? Is the theorem already there. So this directly we can write what is here. S by Es plus sigma copper by E copper equal to delta T alpha steel. So what you write, alpha copper minus alpha steel. If this will substitute this all the value, what is given this value here? If we will substitute this all the value, see here, sigma s will substitute, okay, one more steps I will write here. Okay, due to the space, 2.25 sigma copper divided by Es, okay, Es only write, value you substitute, plus copper by ECU equal to, what will write here, that I will rub it here, these two, and I will write at least one steps, equal to delta T. Delta T will be there, how much they given here? Tighten, rise the temperature of the 50 degree. So 50, then alpha thermal expansion they given already value 18 minus right here 10 power minus 6 you take common, 18 minus 12. If you will solve this, I will write here what you will get here. If you will solve this, how much will get? Es value you substitute here, how much Es steel will be 200 into 10 power 9. Here value will be 100 into 10 power 9. If we will solve this, already we calculated, so what is this value will come? I will show now. So this value will come, if we will solve this, 2.125 into 10 power minus 5, or this long it will come. So finally answer I am writing, if we will solve this, sigma Cu first will come. Sigma Cu will come 14.117 Newton per mm square. And this relations here is there, sigma s. Sigma this into this it will come, it is coming 31.76 Newton per mm square. So what is there? This is the formula. And this is the formula. Two formula if you have, you can get the relation. Then here you substitute all the value is given here. If you substitute, you will solve, both value you will get here. So what they are asking, calculate the stresses developed in the copper and steel tube. So these big questions also you can solve in the 2 steps only. But only calculation parts, one more steps you have to go through. Okay? Okay, sir. Thank you.